Hello, Data Science Nation. Matt here. In today's video, we're going to learn SQL syntax that you will be using in your data science career. I use the SQL syntax covered in this video frequently, and this syntax is easily translatable to MySQL or Postgres if your company will be using either of those SQL databases. Check out the previous video if you need to import the backup database that we will be using throughout this series of SQL tutorials. The link to the video should be in the top right corner of the screen. The GitHub links for all the code in this video and the database backup file are in the description. Let's start by simply selecting specific columns from a table. If we look at the product table in the DSN Healthy Snacking database, we can see the columns by expanding the columns branch. In a new query window, type select, followed by the desired column name. In this case, we're going to look at the product name column. Then we type from, followed by the table name from which we are querying. Since we are querying a table from the DSN Healthy Snacking database, we have to tell SSMS that we are using that database by using the prefix DSN_healthysnacking. Before the DBO.product. However, we can do it another way by clicking the database drop-down menu and selecting DSN_healthysnacking to let SSMS know that is the database that we are querying directly. Then we do not need to specify the database name in the query itself. Go ahead and hit the F5 key on your keyboard to run the query, and you should now see the product name column with all 5 records in the window below the query window. Now, let's add a few more columns to our output. Be sure to separate each column name with a comma. Let's add the cost and the sales price columns and then press F5 to run the query. Now you can see the product name, cost, and sales price columns in the output window. What if you want to select all the columns that exist in a table? Typing all of those out would take quite some time if your company has large tables with thousands or even tens of thousands of columns or more. SQL provides a nice shortcut for this. We can use the asterisk symbol, also known as the wildcard, to select all available columns in a table. Press F5 and now you can see all the columns that are in the product table. Many times, the tables you are working with will have a large number of records. So if we want to only see a preview of the data in the table, we can use the top function to see only a certain number of records. Let's select the top 2 records from this product table. In front of any column names or the asterisk symbol right after select, type top followed by parentheses and the number of records you want to select inside the parentheses. Press F5 and you will now see only the first 2 records in the product table. In a real business setting, you will be showing data to customers, whether that be actual external customers or internal customers such as the sales department or management. They most likely want to see column names that look more like they belong in a published report. We can rename our columns inside our query, so we don't have to do that when we are creating reports in other programs such as Excel, Power BI, or Tableau. This is where column aliases help. We simply use the keyword as between the column name as it is stored in the database and the desired name we want in the output. Let's select the product name but with an alias of product name, all one word, instead of product_name. Now, when you press F5, you will see the product name column but with the alias that we assigned to it. The data is the same, it just has a different label. What if you want a space in your column name alias? SQL doesn't necessarily understand the column name with spaces unless you tell it that the group of words is one column name. You can achieve this by placing the alias in square brackets. Press F5 and you will see the column name with a space to make it more readable to end users. We can also select multiple columns and give them all aliases. Let's select the product name, cost, and sales price, and give them all aliases, product name with a space, cost, and price respectively. Now when you press F5, you see that each column has an alias that is more appealing than the underscores and lowercase names before. Let's take a look at the orders table. Notice that the full orders table has 105 records. You can see this at the bottom right of the output window. Select the distinct customers in the orders table using the distinct keyword. Note that SQL does not worry about whitespace like Python does. However, it is important, especially in a business setting, to write your code in an easily interpretable way because others will most definitely be either reviewing it, referencing it, or utilizing it. Now you should see all the unique customers that we have in the orders table. You can also select distinct groups of columns. For example, let's select distinct customer ID and product ID from the orders table. If you were to look at the orders table in full, then you would find all of these combinations of customer ID and product ID for at least one order. SQL allows us to filter a table using a where clause, which contains one or more criteria to filter on. Let's select all records where the customer ID is equal to 1. Now you should see only the records where the customer ID is equal to 1. You can also filter numeric columns based on comparison operators. Let's select all records where the total revenue is greater than 800. As you can see, we only have records now where the total revenue is greater than 800. You can use the between keyword to select a range of values. Note that between includes both the left and right endpoints of the range that you provide. For example, let's select the records where the total revenue is between 750 and 1,000. Now you can see that there is a record with total revenue equal to 750 and another one equal to 1,000, as well as all values in between. You can also select records based on a list of values enclosed in parentheses. Let's select all records that have a product ID in the following list: 1, 3, and 5. Now you can see that we only have records where the product ID is equal to 1, 3, or 5. What if you want to select records that have a column value similar to some criteria? Let's query the product table and select products that begin with the word organic. We can do this by using the like keyword followed by the string in quotes and the % symbol, which tells SQL that we want all product names that begin with organic. Now you can see that we have 2 records where the product name starts with organic. Let's take a look at the product table. Notice that the product table is ordered by the product ID in ascending order. Let's reorder it by the product name column. Type order by, followed by the product name column. Remember that the default ordering is ascending. Now you can see that the table has changed order and is sorted alphabetically by the product name. Let's return the table to its original order by simply ordering by product ID. Now, let's sort the table by product ID, but in descending order. We do this by using the keyword DESC. Now you can see that the table is in order from largest product ID to the smallest product ID. You can also order by multiple columns. Using the orders table, let's order by the date of the order, and let's order by the total revenue. When you press F5, you'll now see that the table has been ordered by date first, and then for each date, it orders by the total revenue. Let's take a look at the orders table again. There are multiple orders for each customer, so it makes sense that a business may want to aggregate data based on the customer ID. So let's do that. After the select and the from lines, we use the keywords group by, followed by the column name we want to group by. But what is group by doing? It needs something in the select statement that tells it what to do when it groups the records together. First off, you should include the column that you are grouping by. That way it is included in the output table. You must also tell SQL which aggregation method that you will be using when the groups are created. For example, you could sum the total revenue by customer. So you type in sum, followed by parentheses, and put total revenue inside the parentheses. This will return a table that gives us the total revenue summed up for each customer ID. However, you'll notice that there is no column name for that sum. So what we can do is give an alias to that summation. After sum of total revenue, type as, and in square brackets, type total revenue with a space. Press F5 and you'll now see that we have the summation column with the new column name. We can also calculate the average total revenue. The average is calculated using the AVG function. Let's replace the column alias with average revenue instead of total revenue. Press F5 and you now see the column that has the average revenue for each customer ID. We can have multiple calculations from the group by query. Let's calculate the maximum total revenue using the max function and the minimum total revenue using the min function for each customer ID. When you press F5, you now see that each customer ID has two columns associated with it, the max revenue and the min revenue. Many times it can be helpful to know how many orders there are per customer. So we can use the count function and name it order count. Press F5 and you'll now see a column with counts for each customer ID. If you add them up, they add to the total 105 records that we saw before. There is also a way to count only the distinct values in a table. Let's count the distinct product IDs for each customer ID. Of course, in this case, each customer has purchased all 5 products that we have, so they all have the same distinct products purchase count. Using the orders table, let's assume that we want to select all of the columns, but we want to add a new column based on the contents in an existing column. We want to assign a product name based on the product ID. We can use the case-when statement provided by SQL, which is similar to an if-then-else statement in other programming languages. This command will take up multiple lines, but you can space these lines however you'd like since SQL does not care about whitespace like other programming languages, such as Python. Since we are assigning different values based on the product ID column, each product ID will have its own when statement followed by its then value, which is the value that the product name will take based on the product ID. Once you are finished writing the final when statement, you can end the case statement with an end as product name, which, if you remember, is an alias. This is not typically what you will do in a business setting with the case statement, but it is a great example for understanding what case statements do. Let's go ahead and move on to SQL Joins where we can achieve this same output in a much simpler way. Let's go ahead and cover SQL Joins. Let's leave some space under the select statement and we'll fill that in later. We are wanting to join the orders table to the product table so that we can have product information available with our order information. This would be considered a left join because we want to keep everything in the left table and find only the related values from the right table. You can think of the left and right tables as being either on the left or the right side of the join keyword. So the orders table is on the left and the product table is on the right. We need to specify which columns that the tables have in common so that SQL knows how to relate them. We can do this using the on keyword, followed by the equality statement that contains the two columns from the left and the right table that have related values. In these tables, they both have a product ID column, so SQL will look up the product ID from the orders table and find it in the product table, and then return the value from the column that we specify in the product table. Now we can go ahead and fill in the portion under the select statement. We need to tell SQL that we want all of the columns from the orders table, as well as the product name from the product table. If you go ahead and press F5, you'll see the same table that we got whenever we used the case when statements, except we used a much simpler query. Note that there are many types of joins and there are even anti-joins, but we will save those for other videos. You'll notice that we put the table name dbo.orders and dbo.product as a prefix each time we wanted to use a table. We can do this in a much less verbose way by writing this query in a way that involves aliases. Just like we can use column aliases, we can also utilize table aliases. So instead of having to type out dbo.orders or dbo.product every time, we can just use the alias. Place the alias right after the table name in the join statement. Let's call the orders table capital A and the product table capital B. Then we can go ahead and replace the dbo.table prefixes with these new aliases. And there you have it. That is the SQL syntax that you will most likely be using each time you need to access data in a SQL database. I use this exact syntax so often in my data science career, and while it may seem simple, it's extremely powerful. Try it out for yourself and combine some of these techniques to create more complex queries. I'll see you next time.